Okay, Mr. Gazda here. 646. Difference in arrival times of P and S waves. These are earthquake waves, primary waves, secondary waves. But for now, let's just worry about the math. P wave arrives first, primary. S wave arrives second at this time. What's the time difference between them? So you need to rewrite them, and we have the space at the bottom of the page for you to do that. So I'm going to do that. Higher number on top. 9, 15, 30 minus 9, 11, 10. Okay, so can I take 10 away from 30? I can. No need to borrow. 0, that becomes 2. Carry down the colon. That becomes a 4. And then that's 0, and that's 0. So 4 minutes, 20 seconds. You can write it like this if you'd like. 4 minutes, 20 seconds. Okay, so here we go. 4 minutes, 20 seconds. Okay? Second one. 2 this time and this time. We're going to subtract them. That goes on top. Here we go. 2, 17, 20 minus 2, 14, 30. Can I take 30 away from 20? I can't. I need to borrow. Here we go. That becomes 17 minutes becomes 16 minutes. I am borrowing. Every time I borrow across these colons here, it should be like warning, warning. This is not regular borrowing because it would bring 60 seconds over. Cross this out. Add 60 to it. 60 plus 20 is 80. Okay? So now I have 80 minus 30, and that's just like this, and that becomes 50 seconds, and then that becomes 2. So it's 2 minutes, 50 seconds, and you can write it like this. 2 minutes, 50 seconds. You need to rewrite it like this. Pretty much almost every kid who told me they didn't need to do, I don't need to do that, man. It turns out they're wrong, and you know what? They did need to do that, man. Write it out like this. Rarely can you do it in your head. Rarely. And if you can, you're much more likely to make mistakes in your head. So, write them out like this. Trust me on this one. Okay. I need to 45. I can take 45 from 30. I can't. I have to borrow here, so that becomes 3. Don't forget, sound that alarm in your head. I'm bringing 60 seconds over. That becomes 90, and then when you do that math, you go like this, and you go like this, and that's 45 seconds. And then you gotta. This is just normal borrowing though, because you're not going across the colon. So you just go like this. You go like this. That becomes 13, 6. So that's 6 minutes and 45 seconds. Okay, 4 is going to look like this. 11, 27, 35 minus 11, 19, 10. Can I take 10 away from 35? I can. So I don't need to borrow. 5 minus 0, 3 minus 1 is 2. And I do need to, I can't take 9 from 7, so I'll do my just regular borrowing the way you've always done it. 17 minus 9 is 8, and that's zeros. So that one right there, number 4, is 8 minutes, 25 seconds. Okay, and then number 5, let's do number 5. It's going to look like this. 3, 19, 20 minus 3, 15, 35. Can I take 35 from 20? I can't. I need to borrow. 8. Don't forget. 60 seconds plus that 20 is going to be 80. Okay? I can't take 5 from 0. I borrow, like that becomes 7. That becomes 10. And then that's 45. And then that's 3 minutes, 45 seconds. Can you dig it? Okay? Now, why do we need to know this? We're going to get insight into that when we go to the back. Page 11 of the Earth Science Reference Table. Luckily, I have one right here. This is page 11. It's page 11. So what this has is epicenter distance. Epicenter's like, wait, I don't know if you can see that. Epicenter's where the earthquake happened. The center of where the earthquake was. This is distance. This is in thousands, 10 to the 3, and it's in kilometers. So that's not 1, that's 1,000 kilometers, 2,000, 3,000, 4,000, 5,000, 6,000. Travel time here, this is in minutes. 1 minute, 2 minute, up to 24 minutes. And each minute's broken down into 3 boxes. So if you were to count them out, they're not worth tens, they're worth 20 seconds apiece. That's 5:20, 5:40, and then 6 minutes. So, and then this is the P wave line, so it tells you in how long it takes to travel 4,000 kilometers. For a P wave, it takes 7 minutes. And an S wave, this is the S wave line. S waves travel slower, and we're going to be learning all about this chart. Here we go. So I'm going to go like this. So, how long does it take an S wave to travel 3,600 kilometers? So, here we go, 3,600. So, these go by 3,000, 4,000. Can you see that? This is these are 200, so that's 3,200. This is 3,600, and I'm looking for an S wave. So I'm going to say 3,600. Let's just go up to this line and go up like this, up to there, up right to there. Okay. And follow it over, and that is 11 minutes 40 seconds. Okay, 11 minutes and 40 seconds. Okay, 11:40. So this is where it gets a little tricky for people using this chart, so we get a lot of practice. How far does a P wave travel in 5 minutes and 20 seconds? So now, how far is going to be a distance? What are we doing? 5 minutes and 20 seconds. And you always got to remember what you're doing. P wave, 520. So 520 is, where's my pencil? 520, I'm sorry, in 5 minutes, 20 seconds. So now I got to go here. 520, and I'm doing, what am I doing? A P wave. 520 is here. I go over here to the P wave. And then I follow it, where am I? 520 to here, follow it down, it's right there. Count that out. 200, 400, 600, 800, 2,800 kilometers. Okay, so the goal is to really get you to know this chart, and you can answer it, figure a lot of different things out. Time differences, and something like this. How far does an S wave travel in 3 minutes and 20 seconds? S wave. S wave, 3 minutes, 20 seconds. Okay. So now I'm doing 320. Where are my? 320 is here. I'm going to an S wave. 320 is here. I go to here. Follow it down and realize that that right there, 200, 400, that's 800. It travels 800. Oh my goodness, look what 800, look what I did on number 2. Can you believe I messed that up? I did not put units. Oh my goodness. Oh my goodness, I have 1,000 apologies here. You must write the units. It's kilometers, very important. Okay, I am glad that I caught that. 4. How long does it take a P wave to travel 3,200 kilometers? How long is going to be in time? P wave 3,200. P wave, so P is this chart, 3,200 is here, go upright, oh look at that, it falls dead on that number. 6 minutes even. 6 minutes. Maybe, for us, 6 minutes, 0 seconds, so no, it's exactly 6 minutes, okay? 5, an earthquake occurred 2,000 kilometers away. The P wave arrived at the seismic station first, then the S wave arrived. What was the time difference between the arrivals of the S and P waves? So, I could do it like this. So 2,000. So 2,000, it took, I'm going to round this to 4 minutes for a P wave to get there. So P wave took 4 minutes, okay? And then an S wave took 7 minutes and 20 seconds. 7 minutes 20 seconds. So hopefully you can realize that just maybe by eyeing it up, that is 3 minutes and 20 second difference. 3 minutes 20 seconds difference. Okay, one thing we're going to start doing in a minute, I'm going to show you another way to do it. I don't expect you to do it yet, but we will be doing it, so I'll show you now. Check out the time difference. We're going to do it this way. The time difference is represented by this gap right here. Okay, that's what the time difference is. Now, we had kind of pretty straightforward math right there, but we're also going to do it like this. Although you'll be marking it with a pencil. You're going to go like this. You mark that gap there very accurately, okay? You like that and like that. And then, if you put it down here on the chart, you put it down right there, guess what that is? 3 minutes and 20 seconds. And I think a lot of people find that to be easier. So we'll be doing that. Trust me, we'll be doing that. So that's cool. And I just wanted to show you that. And then 6, how much longer does take an S wave to travel 4,000 kilometers compared to a P wave? So now we're doing 4,000. Now we're doing 4,000. So 4,000, a P wave takes 7 minutes. 7 minutes for the P waves. Maybe I'll write that down for the P wave. And then it takes an S wave 12 minutes and 40 seconds. 12 minutes 40 seconds. And you could write the math out if you want, but you're probably going to end up with 5 minutes and 40 seconds. 5 minutes 40 seconds is the time difference. Now you also can do it this way, as we said. What are we doing? You could, just to show you this, we can do it like this. Put this up. Marking it accurately is important. Mark the bottom with your pen or pencil, and mark. Don't put the bottom of the paper here. Don't do it. Don't do it. Trust me. Don't do it. I've seen a lot of kids do it. I've seen a lot of those kids get it wrong. Don't do it. Go like that, and then if I put it here, it is going to be 5:40. Look at that. Put it right there. It's a little less than 5:40, but basically 5:40. That is another way, and we'll be doing that a lot. So it's another way to do it. So this is a good introduction to page 11 of the reference tables. I'm Mr. Gazda. Thank you for watching.